Okay, so let's talk more about limits and see that we can understand how to solve those algebraically. So hopefully you're getting a little bit more comfortable with solving them graphically now and being able to see that if the right and the left-hand limit are the same, then the limit exists and it is what that value is. So let's look at algebraically. It gets a little bit trickier solving these, but not too bad. So you've already learned about substitution. So simple enough, if you want to find the limit as x approaches 2 of a function, let's say x squared minus 3x plus 5, then using substitution, you can just plug 2 in anywhere that there's an x, and we get 2 squared minus 3 times 2 plus 5. So we get 4 minus 6 plus 5, which that would just equal 3. Is that right? My mental math is not always super fast, mostly when I'm talking in front of people. So yeah, this negative 6 and the 5 gives us a negative 1. We have 4 minus 1, so that should be right. It's 3. Okay, so what happens when substitution fails? And what I mean by that is, what if I have... So when substitution fails. So what if I want to know the limit as x approaches 0 of x squared plus 3 over x? Well, what's the problem with this? Let's start to substitute in. So let's try substitution. We would get x squared plus 3 all over 0. Simplify that down, we get 3 over 0. Well, what's the problem with that? Well, right there, if the denominator equals 0, that's a problem because we can't solve that. That's undefined. Okay, so substitution didn't work in this case. So let's go through and look at another step that we can take. And I just made this one up. I'll show you one that we can use another step. So let's do another example. So that one I was just showing you, substitution did not work. So here's one that substitution also does not work in. We're going to take the limit as t approaches 2 of t squared minus 3t plus 2 all over t squared minus 4. Okay, so using substitution. If we use substitution, we plug this in and we get 2 squared minus 3 times 2 plus 2 all over 2 squared minus 4. Now notice just right now, we're going to get a 0 in the denominator. Okay, so this is why substitution does not work. Okay, so the other thing that you can do is we can actually simplify our equation before we take the limit. So we're going to take this, we're going to keep it as a limit. So we're not going to take the limit yet. And we're going to simplify this equation. Okay, so first of all, we need to use knowledge that we have that if you don't know this, we need to make a flashcard of it. Anytime you have two perfect squares that are subtracted from each other, this is called the difference of squares. So we're going to take the difference of squares to help us to factor this out. And I will go through that in a second. So t minus 2 and t plus 2. And then here we're going to go ahead and simplify this as well by factoring it. So you also need to be comfortable once again with that factoring. So t squared, we know the first two terms are going to be t. We need two numbers that multiply together to give us positive 2 and add together to give us negative 3. So we're going to have negative 2 and negative 1. Okay, so now you can see from this that we have a factor of t minus 2 on the numerator and the denominator of our function. So we can take these and we can actually cancel those out. So now what we're actually looking for is the limit as t approaches 2 of t minus 1 over t plus 2. So now that we've simplified, first we're able to take using substitution what the limit is. So now we're just going to substitute that in and we'll get 2 minus 1 over 2 plus 2, which will give us 1 over 4. Okay, so the only thing we had to do different was simplify before we tried to take the substitution. And so that's something that we will, I'm going to write you out a list of kind of the process that we go through in finding out how we're going to solve this. Okay, really quickly, you're going to want to make a flashcard. You should hopefully have that set of flashcards and start creating those. We're going to make a lot of them through the year, so you'll have a lot to study. But we're going to make a flashcard that is difference of squares. Okay, so the difference of squares, what that says is that if you have two perfect squares, so a squared minus b squared, that you can factor that out as a plus b, a minus b. And I'm going to put on the homework a little section of practicing this, and so that you can get used to it if you haven't already. But it's something that you did learn previously, but that you will need, and they'll just expect you to use on a whim, and you'll have to recognize when to use it. So I do want you to put that. So okay, so let's move on and let's try a couple other problems. So let's have one that you guys can try on your own here. So I want you to try this example on your own piece of paper. The limit as x approaches 0 of 3x to the third plus 5x squared plus x over x. So you're going to run into the same problem. If you substitute x straight in, you get an undefined answer because the limit is still just 0. The denominator is 0. So the limit is undefined in this way if we just go straight to substitution. So I want you to use, on your own piece of paper, write this problem down, pause the video right now, and so that you can then try it on your own and simplify the equation first before using substitution to show that it works. Okay, so pause now. Okay, so what you should have done is been able to factor out all of these values have an x in them. So you can factor an x out, and then you have your problem left, and then you have the x in the numerator and the denominator that can eliminate each other. And you're left with just the 3x squared plus 5x plus 1. You plug a 0 in, you get 3 0 squared plus 5 times 0 plus 1, which is just equal to 1. So once again, we were able to use simplification first to make it so that substitution would work. Okay, another problem that you may run into, so the one thing we recognized is if there's a 0 in the denominator, that you can't just substitute straight across. Something else that may prevent you from substituting straight across is possibly having, like radicals can sometimes cause problems. But let's look at this again. You do need to be comfortable with radicals, and so let's make sure we can add this into. Okay, so what if I have the limit as x approaches 0, the square root of x plus 1 minus 1 over x. Okay, so first of all, it is the same problem. If we plug in a 0, we're going to get a 0 in the denominator. Now, I want you to notice if we plug in a 0 into this, we'll get a 0. Also, if you plug a 0 into the numerator, you'll get the square root of 1, which is 1, minus 1, which is 0. Okay? The answer, even though that's not correct because it's undefined, is 0 over 0. I want to make a little note. Be suspicious of 0 over 0. So when you're calculating these, sometimes they just don't have a limit. But sometimes, if it's 0 over 0, that's when you really need to make sure you're being suspicious and you're trying more as far as doing the simplification and what I'm going to show you here with the rationalization. Okay, so we can rationalize this equation. And if you remember rationalizing, we take, you take the factor on the top and we're going to multiply it by what's called it's like a conjugate, I believe. So let's do that. So I'm going to take the top and the bottom, and the conjugate would be the square root of x plus 1 plus 1. So see how this one's minus 1? And we're going to multiply that by the top and the bottom. This would be rationalizing our numerator on this. So we're getting rid of the radical there to see if that helps us with the problem. Okay? We're not getting rid of it completely as much as just simplifying it by using rationalization. So that's going to be one of the other techniques, is rationalize. Okay, so we need to simplify this all out. So now we need to take and multiply this out. So what is the square root of x plus 1 times the square root of x plus 1? Well, to simplify that down, what's the square root of 2 times the square root of 2? Well, they undo each other because you're going to have them squared and the square root, so it's just 2. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. And that's why it's called rationalizing this way too, is it gets rid of that. Okay, now we're going to take the square root of x plus 1 times 1. But notice the way we set it up too with rationalizing is that now this is going to be multiplied by the negative. So minus x plus 1. And then multiply the back part. So these are going to cancel each other out. And then the denominator I'm going to keep like this for a second here. Okay, so now I have the limit as x approaches 0 of our the x plus 1 and minus 1. So we just have x left on the numerator. And then we'll have x times the square root of x plus 1 in the denominator. Okay, so now notice just by doing this simplified out all of those where now the x's cancel each other. So now we just have the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. So now when we plug these values in using substitution, 0 plus 1 is 1, the square root of 1 is 1, and you'll have plus 1. So you have 1 over 1 plus 1. So the limit would be 1/2. So rationalizing, that also gave us what we needed. Let's go through the steps now of what there is. I think actually let's do one more really quickly. So this one we were able to solve using rationalization, then simplification, then substitution. So what if we have something like this, where it says the limit as x approaches 2 of x cubed minus 1 over x minus 2. Okay, now first of all, we, in this problem, we can't substitute straight in because we'll get 2 minus 2 on the bottom, which would be 0. And notice if we plug a 2 in the top, it would give us 7. So we have 7 over 0. So remember when I was talking about how when you see 0 over 0, that's like creepy. It's like something else is going on. When you see 7 over 0, it's not really as, you should be more sure that it maybe doesn't have a limit. You still need to check it out. I'm just telling you that that's kind of like a key. The 0 over 0 is really suspicious. But notice this is 7 over 0 if we just plug it straight in. Okay, we still can't solve it that way. So we try and go and say, okay, well, can we simplify it? No, because there's no common factors between the top and the bottom. Can we rationalize it? So could we take x plus 2 and try and get rid of something? Or x cubed plus 1. Rationalizing doesn't really work. And so then we go into graphing. So we're saying, okay, let's try graphing this and see what is actually happening with this function. And sometimes that helps us to understand a little bit more too, so the last thing you want to do is to graph, to look at it. Okay, so we're going to go ahead and graph this to look at it. So the way that when I say to graph it, what you need to do is you're going to take x cubed minus 1, and you probably do need to have, let's see, in my calculator, I'm going to need to have parentheses around that. If you have a newer calculator, it might help you with it. And then on the bottom, I'm going to put x minus 2. Okay, now because of time, you would need to find a window that really fits this. I'm going to go ahead and tell you that the best window is -10 to 10 on your x, but then you're going to want a lot bigger on your y. So we're going to go -100 to 100 on your y. Just for the best viewing window. Sometimes it takes a little time. Like I said, my calculator's a little bit older. Okay, so there we have our graph. Make sure you can see it there. Okay, so when we look at this, when we look at the value at 2, notice, and it's hard to see on this graph, let me actually show you the graph in the book so that you can see it a little bit more clearly. Because it's hard to see my graphing calculator on this camera. But on here, this is actually that same graph. So when we take that graph and you look at 2, see what is the limit as x approaches 2 from this left-hand side? So see how it goes down as it approaches 2? It actually goes down to -infinity. This limit on the right-hand side as it approaches 2 goes to +infinity. Okay? So the limit of the right and the left-hand side actually do not equal each other, which based off of our definition, that means that the limit does not exist. Okay, so you can see graph, or you can graph it on your calculator. See graph on page 63, and it's figure 2.4. Okay, just in case you want that for your notes, and then that way you can look at it that way. It's really easy to see. Okay, so that way when we looked at it, we said, oh, well, of course, the limit doesn't exist because the right and the left-hand limit are different. Okay, so let's talk about finding a strategy for finding limits. And this is something that you may want to make a flashcard of, just to keep, because I'll probably ask you this on tests, and actually just as a question, I'll say, okay, I want to know the steps or the strategy for solving limits. Okay, so what's the first thing that you always want to try? The most simple thing and the best thing to always try first is substitution. Okay, so we want to try substitution first. If the substitution fails, what's the next thing that you want to try? Simplification. Simplification. Or simplify. Might be an easier word to write, but it's okay. So simplification, you may want to write simplify or cancel. Okay, so cancel, simplify, make the equation more simple. If that doesn't work still, then you may want to try rationalizing. So rationalize. And then the last one would be to graph and make sure what's really happening on your graph.